Have you ever wondered if there's a single theory that could explain everything about the universe? Welcome to the Curious Culture Club, where today we delve into a theory that aspires to do just that, the string theory. This intriguing concept emerged not from a singular brilliant mind, but from the collective efforts of numerous 20th century physicists who spent years in relentless pursuit of a unified theory of physics. String theory steps up to this challenge, proposing to harmonize the seemingly discordant forces of nature, a coherent symphony. It suggests a radical idea, that the universe's fundamental building blocks aren't particles as we've always thought. Instead, they are minuscule, vibrating strings of energy, each playing their unique note in the cosmic orchestra. So imagine, if you will, a universe not made of matter and particles, but of tiny pulsating strings, each contributing to the grand harmony of existence. In this enthralling world of strings, the universe as we know it takes on an entirely different perspective. If the universe is a symphony, then according to string theory, every note that these strings play is a different particle. Imagine the strings of a violin. As you pluck each one, it vibrates at a different frequency, producing a unique note. In the world of string theory, these frequencies translate into different particles. So an electron might be a C, a quark could be an A, and so forth. Now let's delve a bit deeper. String theory also suggests the existence of extra dimensions beyond the three of space and one of time we're familiar with. Think of it like this. Imagine a tightrope walker. To us, the rope appears one-dimensional, but to an ant on the rope, it can explore another dimension by moving around the circumference. Similarly, these extra dimensions could be right under our noses, but too small for us to detect. These extra dimensions, hidden to our senses, could hold the answers to some of the deepest mysteries of the universe. However, like any groundbreaking theory, string theory has its fair share of criticisms. It's been called the theory of everything, yet, ironically, one of the biggest controversies it faces is its lack of testability. Critics argue that the theory, while mathematically beautiful, doesn't provide concrete predictions that can be tested in experiments. Moreover, the absence of empirical evidence supporting string theory has drawn criticism. Despite the theory's allure, its extra dimensions and vibrating strings remain elusive to scientific detection. This has led some to question whether string theory is more of a mathematical framework than a physical reality. Yet despite these criticisms, many physicists remain invested in its potential. They argue that string theory, with all its complexity and abstraction, may hold the key to unifying the fundamental forces of nature. The lack of evidence does not deter the pursuit of knowledge, but rather fuels the quest for deeper understanding. So, where does the journey of string theory take us from here? As we look to the future, the prospects of string theory are as enthralling as they are enigmatic. The potential for experimental validation of this theory is one of the most exciting areas of research. Scientists around the globe are striving to find ways to detect the extra dimensions or the supersymmetric particles that string theory predicts. If successful, these experiments could provide the much-needed evidence to establish string theory as the grand unifying theory that Einstein dreamed of. Ongoing research is also focused on unraveling the complexities of the theory itself. Leading scientists are digging deeper into the mathematical foundations, hoping to uncover new insights that will further our understanding of this intricate theory. The future of string theory is a vast landscape of possibilities, teeming with the promise of new discoveries and groundbreaking revelations. Whether string theory will eventually be the key to unlocking the secrets of the universe, only time will tell. String theory, with its promise of unifying all of physics, offers a tantalizing glimpse into the fundamental nature of reality. From its birth as a theory seeking to reconcile quantum mechanics and general relativity, string theory has evolved into a vibrant field of research, pushing the boundaries of our understanding of the universe. Through the lens of string theory, we've explored the concept of vibrating strings as the building blocks of matter, the existence of extra dimensions beyond our perception, and the principle of supersymmetry. Despite the controversies and criticisms surrounding its testability and lack of experimental evidence, string theory continues to shape our perspectives on cosmology and particle physics. The future holds immense potential for this enigmatic theory, with ongoing research striving to provide experimental validation and further insights. As we continue our journey of discovery, one thing is certain. The universe is far more fascinating and complex than we could ever imagine. Stay curious with the Curious Culture Club.